So again, welcome to stream number 3. Today we're going to be talking about a variety of keylogger related things. We're going to look at a piece of malware that I discovered earlier from this year that has a keylogger capability. We're then going to discuss how to write a simple keylogger if you're interested in more of an offensive capability. Then we're going to end by creating a simple utility that will allow us to generically detect certain types of keyloggers on macOS. Now, before I dive in, as always, I want to thank the friends of Objective-C. These are the companies who are supportive, who sponsor my research, the Objective-C tools, the live stream, conference talks, et cetera, et cetera. First and foremost is Digita Security. Digita is my main employee. We are working on Mac security tools for the enterprise. The other friends of Objective-C include Sophos, Malwarebytes, SmugMug, the Guardian mobile firewall, and the Secure Mac. Again, mahalo to them. Very thankful for their support. Okay, so let's dive in and talk about a piece of malware called ColdRoot. And this malware is not particularly interesting, but it does have a keylogger component. And since we're talking about keyloggers today on macOS, it's a great kind of case study. So let's kind of hop in and just start talking about it right away. Background on this was I was giving a talk at Syscan, and I was looking for some proof of concept code that would try to gain accessibility rights to bypass or directly add itself to the privacy database. So taking a step back, in order to do keylogging on macOS, one of two things have to be true. You either have to be running as root, or your application or your piece of malware has to have an accessibility right, which is normally added with user consent to something called tcc.db, which is the privacy database on macOS. So you can kind of see, let's make this a little bigger. In this slide, this is where the database is, and files that have access to your computer, for example, can do things like keylogging, appear here. Now, in older versions of macOS, this database was not protected by system integrity protection, meaning that malicious applications could directly modify this file. And this would avoid, as the slide shows, this accessibility prompt. Normally, if you just try to enable keylogging, it's going to alert the user, and the user will have to manually add it to the database via the UI. But again, there was this backdoor access where you could just directly interact with this database, not have to go through the UI, and this would allow you to gain the ability to perform keylogging, not as root, without having to alert the user. So I basically hopped on VirusTotal and I searched for tcc.db because normally there shouldn't be, in my opinion, any legitimate applications or reasons why code that does not belong to Apple is directly referencing this undocumented system database. And it turned out there was a bunch of known keyloggers, some game hacks, which aren't too surprising because game hacks often, move the mouse or perhaps need to do some similar modifications to your computer. But there was one file that had no detections, but it was called com.apple.audio.driver2.app.zip. I downloaded this file and I looked at some strings, and yes, there was the reference to tcc.db. And above that, we can see some SQLite commands, basically showing that this application, this binary, whatever this was again directly interacting with this privacy database. So very suspect. Now the question was, okay, this is likely suspect, but is this a piece of malware or is it just a research tool, something else? So again, as I mentioned, first it contained reference to tcc.db. This, as far as I know, there's no legitimate reason why there should be reference to this. So I already thought it was suspicious. It also claims to be an Apple audio driver, but if we use one of my utilities, what's your sign, we can see that it is actually unsigned. Now, Apple obviously signs everything, so the fact that there is an unsigned binary that claims to be belonging to Apple is very suspicious as well. Thirdly, it was packed by UPX, super suspicious. UPX is a packer that malware authors will often use to compress or obfuscate their code. Now, there's nothing inherently malicious about UPX per se, but especially on Mac OS, it's most commonly used by malicious adversaries. Let me just tweet to say that we are live streaming. Okay, awesome. And finally, well, when we execute it, it asks for authentication credentials. Again, this is not normal application behavior. And behind the scenes, it does other things. For example, persisting a launch daemon, very suspicious. Tries to connect to some unknown IP address. So again, at this point, I was very confident this was a malicious piece of code, even though none of the engines on VirusTotal were alerting it. So what we're going to do is we're going to look at the keylogger capability of this. So the first thing we can do is we can unpack this piece of malware, which I named ColdRoot. So if you want to play along, you can grab this from the Objective-C website. I'll just post this link here. This is a collection of essentially all publicly known Mac malware. So anytime you see a security researcher tweet about some new Mac malware, or anytime I blog about this, I always will add it to this page. So if you're interested in Mac malware, this is kind of the place to get samples. So we can download the sample. Takes a second. It's going to be a zip file. The password for all the samples is infected, which we can see there with a 3 instead of an E. Yes, super elite. So let's just unzip this. And if we run the file command on this, it's probably going to tell us it's a mock-O binary. Yeah. Interesting, though, it's only compiled for i386, meaning it's 32-bit code. Now, this will run on modern Macs. They will run 32-bit code. But again, all new Apple software, legit apps that are being released are generally going to be compiled with native 64-bit support. So again, just something kind of suspicious about this. So if we hop over to the desktop, I have UPX installed, or sorry, the binary already there. One of the cool thing about UPX is it can unpack things that are packed with UPX. Normally, packers, especially on the Windows side of the house that malware authors will use, are not unpackable with the same binary, meaning like they'll pack it with some custom packer, they'll release that into the wild. Of course, the packed executable will be able to unpack itself, but generally there's not a utility to unpack that unless a security researcher or a reverse engineer or a software programmer person has specifically written that. But again, UPX is nice because you can unpack things that have impact. So if we execute UPX-D, UPX with the -D flag, we can then specify the path to the packed binary. And actually, before we do that, you might be wondering, how do you know that it's packed with UPX? So do I have O2 installed on here? Probably not. Oh, I do. I think it's H. Nope, capital H. What I'm doing is, oh, where's caps? There we go. No, that's not a, see, I don't really know what I'm doing all the time. I'm basically trying to look at the mock-O headers. Maybe it's L. Perfect. Okay, so OTool is a Apple utility that will parse mock-O binaries. And one of the things we can do is we can look at the mock-O headers. And we notice there is a section with a segment name XHDR. This is something that UPX adds. So for example, if we run, again, OTool-L on an Apple binary, so for example, calculator, we will see, okay, let me just do this, put it into less so we can see there's no segment called XHDR, right? It's just standard text segments, C strings, standard mock-O stuff. So if you see that header in a binary, okay, I'll pipe this into less so we can see that. We know this is UPX, right? Cool. So that's kind of a good way to do that. And UPX will also tell you if you go and try to unpack something that's not packed with UPX. So for example, if we do UPX-D and we again specify the path to calculator, contents macOS calculator, it should complain. It should complain and say 0 unpacked files. Permission denied because it's an Apple binary. But let's try. Applications are protected. Apple applications are. But I think if we copy it to the desktop, oh man, CP, okay. And then try to UPX-D it from here, maybe that'll work. Okay, cool. So this will throw an exception, basically saying this binary is not packed with UPX. So that's a way you can also tell if something's packed with UPX. Just try to unpack it, again, using the D flag. Okay, we're going to try to unpack the malware, though, because, again, we showed that it was packed with UPX. So, again, we can execute UPX-D, and this will unpack that. So, again, it says, okay, we unpacked one file, gives you some information. So now the binary is unpacked. And again, if something is packed a piece of malware, you want to generally unpack it because the packer is going to obfuscate various components, making static and dynamic analysis difficult. So I've actually already loaded this in Hopper, which is my current disassembler of choice. So I'll just pull this over here. Again, I've loaded the unpacked ColdRoot binary in here. And what a disassembler or debugger will do is, again, basically show the binary code, embedded strings. And again, this is what I use to analyze, to statically analyze a malicious binary or binary if I'm just reverse engineering it looking for bugs. So if we look at strings, we can see there's a bunch of Objective-C stuff. I always just kind of look at here first to see if there's like debug statements or anything interesting. These are a lot of like Apple strings, so there's nothing really that's standing out too far, sticking out like, you know, an IP address or something. But again, always kind of good to peruse the strings first. Anyway, since we're interested in keylogging, we'll talk about this a little more soon. But basically, the API you use is something, we're going to use the Core Graphics CG APIs. And what we're going to do to capture keystrokes is generate or install something called an event tap. And again, this is the most common technique that malware authors use. So if we think that this malware might be using keylogging capability, we can start looking for that. So we click on proc, which is procedures. These are the APIs. And I think it's called, yep. You can see there are a bunch of these CG event methods. So there's one called get integer value, keyboard get Unicode string, tap create, and tap enable. So let's first hop to this one and let's quickly Google that to get some more information about this. Cool. You can see I already clicked on this. So Apple's documentation says creates an event tap. Now this isn't that informative, like what's an event tap? But we'll show in a little bit, this is how you can capture keystrokes. So the parameters are important. Again, we're going to write our own keylogger shortly, but again, understanding reversing the malware, it's important to understand the API. So the first thing we are of interest is this events of interest parameter. And this is, again, a bitmask that specifies the type of events to observe. So as we'll see, you can specify that you are interested in keyboard events. And once you create an event tap and specify a keyboard interests, once you've enabled it, anytime the user presses a key on the keyboard, what will happen is this callback parameter, which is a callback function that you provide, will be invoked. So again, you get a callback, a notification, anytime the user types something. So again, this is, you know, keylogger, right? So let's go back to the malware. And if we look at this method, what we can do is we can look at the cross references to see who calls it. So you do that by hitting, I believe it's X. And this will show you references, that is code that invokes this CG event tap create. Again, CG event tap create is the Apple API to create an event tap, which we are assuming is going to be used to install a keylogger. So we double click on that, And this takes us to the disassembly. One of the nice things about Hopper is it can decompile code. So it can take it from this assembly code, which is not trivial to read, to more readable C code. So once we do that, this looks like kind of standard C code. So if you're familiar with C or programming, this should be more readable. So the first thing we see is this routine at sub 6A950 calls CG event tap create. And then what it'll do is it'll create a run loop source, and it will enable the tap after it's added it to that. So again, the steps you do, and we'll see when we write our own keylogger to do keylogging, is you create an event tap and you specify the bit mask that says keylogging. I believe it's one of these values. You then add it to a run loop. You then enable it, and now you just basically say run loop run. So this means your tap has now been enabled, and you can think of it just like tapping a phone or fiber optics, right? It's like that's I think where the name came from, where it's like the physical tap on the device. Anytime a keyboard is pressed, the method will basically the key press will go through and will deliver to you. I actually have a slide that pictographically illustrates this. Let me see if I have this. I think it's on speaker deck. So we'll pull this up. If you're interested in all my talks, they're also here. So I'll just post this link really quick. Let's see. I believe it is this one. So in here, there is a slide, a good overview of these CG event things that I'm talking about. Okay, targets, tags, Apple scripts, core graphics APIs. Okay, perfect. This is the one I wanted to show. So again, using core graphics, Apple documentation says that it's a mechanism that you can use to capture low-level user input events. Think mouse and keyboard presses. So pictorially, this is what happens once you've installed a core graphic event tap. User presses a key, A, that goes to the document, but in the background, it will also be delivered to your event tap that you've installed. So again, this is just an overview of this. And again, here's some code that you basically do. You basically specify what events you are of interest. Here we're registering for key down and key up. We then create that event tap, and then we enable it. We also then add it to the run loop, but then now basically a keylogger has been installed. So back to the malware, which is in Hopper, we can see they're doing exactly this. They're creating that event tap. They're adding it to the run loop and then enabling that. When they do that, anytime a key press is registered by the user, it will be delivered to them, specifically that callback routine. So that callback routine is specified when you generate or create the event tap. So in Hopper, we can double click on that, and this will take us to the keylogger callback function. And we can see it does something like getting the Unicode string. So it's going to convert the key press, which is going to be some number, to a string, a printable value, for example, an A. Then it looks like they have this crazy switch statement, which Hopper doesn't really handle, but this is likely to handle like the shift key. So if I hit shift A, that's going to generate 2 events. So what you want in your keylogger is to handle that and say something like shift A is really a capital A. So you always add some extra logic to kind of handle that stuff. Okay, so now we have basically confirmed that the keylogger is, this malware rather, has keylogging capability. We can go run that and we can actually see if, that's really the case. So we're going to go to our VM and we've unpacked it. So let me just run it from a terminal. Downloads. Okay, so sudo downloads, what was it called? ColdRoot. com.apple.audio driver. Again, that's the name of the malware. Contents macOS com. Blah. I believe if we run this, it should. No, we don't want to run it as root because it asks for root. Okay. Oh man, looks like the quality of the stream is a little blurry. Apologize for that. Okay, so let me just see if I can improve that. 1 second. Okay, so when we run the malware, we can see the first thing it's doing, it's asking for our credentials, which is strange. Again, applications shouldn't do that. But in order to modify that privacy database and install a keylogger, as we mentioned, it has to run as root. So this is why it's asking for the credentials. So we put in the password for my VM, which is that, I think. And it's actually kind of interesting. We can see that the malware has some embedded strings. For example, it tells you where it's trying to connect. So if you were interested, for example, in the IP address of the command and control server, the malware is just giving it to us. So in the background, let's go look for the keylog file. I believe it's in private var tmp. Awesome. And I previously analyzed this malware, and also in the blog where we discuss it here, we can see that there is a configuration file that has a bunch of configuration information. So I believe that's also right here. Let's see if downloads ColdRoot. Where was it? Contents macOS. I think it's, yeah, that connex.wall file. Cool. So this is the malware's configuration file. It's plain text JSON, which is really nice. And we can see, for example, the address of the command and control server. And right here, we can see this file, which turns out is the keylogger file. So if we go back to that file, we can tail it, which we can do with tail-f, tell it to follow it. And sure enough, we can see that we are capturing keystrokes. So come on, Spotlight. If I open text edit and start typing, for example, hello, Twitch followers, we can see that the keylogger, it has a bug in it. It doesn't capture the letter C, which I think is hilarious. But other than that, it captures everything we type, as well as the control keys. For example, if we hit Shift, Backspace, etc., etc. So again, the malware is keylogging us. So again, that kind of wraps up the section on the malware. Basically, again, ColdRoot was undetected at the time, has a bunch of basic capabilities, but we showed that once it is installed, it will turn on a keylogger and start capturing things. And I think I have some animated GIF on this. So you can see if you go, for example, to a browser and type in your username and password, depending, I think, on what version of macOS, even some of the password fields will be captured. So if you want more information about this malware, I'm just going to post a link to the blog right here. But again, it's just a good example of a piece of Mac malware that captures keystrokes. So now we're going to switch gears a little bit, and we're going to talk about writing our own keylogger, which you might want to do. Josh has a question. I always wondered why the C in Patrick Wardle wasn't captured. That is very observant. So you can see that when I log in here, the malware actually missed the C in my name. So there's a bug in the keylogger. I haven't tracked down exactly what the bug is, but yeah, it's definitely they just don't capture that. So use a lot of C's in your password, because then if this malware is installed, it won't be able to capture them. Okay, so let us start a new Xcode project. I'll pull this over to the screen in a second. And what we're going to do is we're just going to create a simple keylogger that will capture key presses. Basically, we'll show what the attacker did. And if you are writing your own malware, yeah, actually, just forget I said that. So we start, we're going to just name this Twitch key logger. Yeah, let's make sure to create right here. All right, so let me just move this over here so we can see this in the Twitch stream. Just double check on that. Okay, awesome. And And okay, so this is Xcode. We're going to write some Objective-C. I have some of this code already typed out because I don't think you want to just see me sit here and type. But the first thing we're going to do is we're going to specify, okay, so we have to import the header files we want to use, specifically, I think it's carbon.h. And that has the CG core graphics APIs that we need. For example, the CG event, create event tab. So in our main function, we're going to install the keylogger. The first thing we need to do is we need to specify an event mask. So the event mask, again, is the things that are of interest, because there are various event taps that you can create. So you can create, for example, one to capture mouse movements. So if you're interested in sniffing the mouse, I don't know why you would be, but you can create an event, a CG event tap that monitors for the mouse. The next thing we need is this run loop source. This kind of gets into some lower level Objective-C runtime stuff, but basically the run loop is kind of the main activity event pump that is always running. So basically what we'll do is we'll create an event tap and we'll add it to the main run loop that basically tells the operating system that anytime there's an event, we are interested in it and deliver to us. So this is just something we have to do. Okay, so now let us specify what we want for the event mask. That is, what type of events do we want to capture? And since we're capturing or creating a keylogger, we're going to specify that we are interested in key down and key up events. So right here, we basically use this little CG event mask bit macro, and we basically pass it these two constants, which are key down and key up. And this basically tells the operating system these are the two events we're interested in. So once our event tap is installed, anytime that there is a key down or a key up event, we will get that. Okay, let me see if I can make this bigger. I don't know how. Oh, perfect. Make this a little more readable. Okay, let me just hop over. Okay, hopefully this is more easy. So again, this is our event mask. Okay, so we've basically not really done much yet, but what we are now going to do is create our event tap. So first, let's make a variable for this. It's going to be a global variable because I think we want to reference it in our callback function. So this is the event tap we're going to create. We just declare a variable for that. We then come and we are going to create it using the CG event API. So this is how we create the event tap. And again, we talked about this API. We say it's a session event tap that just says we're interested in all global events. We say we want to put it at the very start of that. We pass in our event mask, which again, we specified for key down and key events. And then we specify our callback, which we haven't defined yet. Again, this callback is going to be invoked anytime there is a key press once we have installed and activated this event tap. So let's now do that. So let's go implement this callback. The function definition for this is right here. It's a little long. So again, I'm just copy and pasting this code. And let's see, this should compile in theory. Fingers crossed. Oh, we need to return something. Return 0. Okay, awesome. So this compiles. Again, we haven't enabled the event tap and we haven't done anything in our callback, so nothing is really going to happen yet. So now let's add some functionality to the event callback. And again, what this is going to get is it's going to have a type. This type is the type of the event. So this can be a key down or a key up. If we registered for mouse events, this would also be the mouse up, mouse down, mouse move event. So this is how you know what type of event occurred. So what we can do is we can basically handle those events, or since we know it's a key event, we can do something like this. So we can say if type equals it's KCG event key up, printf key up, else if type equals case key down, I think it's called, event key down, printf key down. Okay, and we should probably put some new lines here so it's more readable. Now we're not printing out what key was pressed yet, but we're just saying, hey, a key down was occurred. You could probably implement this in a switch statement, but if else if is easy. So again, this logic basically is checking the type. This is passed into the callback. And again, it's important to understand that this callback is invoked automatically by the operating system once you've created and enabled an event tap. So now we have to go back to this event tap. We've created it, but we haven't enabled it nor added it to the run loop. So what we can do is we can implement that now. So what we do is we create a new run loop source. This is just something that you have to do. And again, we pass in the event tap we've created. So this will add, again, a new run loop source. We then are going to add it to the current run loop. Again, run loops are kind of complicated. I don't even really understand them, but it's kind of like the main thread of activity that's always running. So basically, we're adding our event tap to that so that then the main thread can go off and run. And anytime a key press occurs, we get invoked. So again, we created that run loop source, and then we added it to the current run loop. Again, note we pass this variable to that. Cool. Now, the last thing we have to do is enable the event tap. So again, we've created it, we've added it to the run loop, and now we're going to enable it. So I'm going to add a little comment, enable it. Awesome. Now, the last thing we have to do is we have to tell the main run loop just to run. So this is basically just going to tell the main thread to run, do its thing. And now, since we've added an event tap, in theory, whenever we press a key press, we're going to get an event. So let's build this. Show this in Finder. Okay, awesome. I'm going to copy this to the VM because we need to run this as root. I'm not going to type my root password, to my main box while I'm streaming. Okay, so let's see if this works. So let's cd to the desktop, sudo/Twitch Keylogger. Put in the password. And then if we come to here, it's working, cool. Oh, okay, so if you notice, I'm typing in this window right here, but my key presses aren't actually showing up on the screen. And that's because we have a bug in our code. But you can see that anytime I press something, so I'm going to press the letter A, we get a key down and a key up. And this is because when you press a button on the keyboard, it generates a key down and key up. So now we know basically our event tap is kind of working. But we have a bug in it, and that is none of the key presses are actually being accepted. So I can't even control C this. So let's revert this VM because I broke it. Don't save. And the bug we have is that in here, we return 0. And I think what we need to return is something that basically says that we don't want to handle it and that it should be passed on. Because I think when you return 0, you're basically telling the operating system that you consumed and intercepted that key event, and you actually don't want it to be delivered. So you can actually block key presses as well. So what we need to do is we need to return the event that was passed in, and that just passes it on to the system. So now if we come here and we put event, which again was passed in, this will be displayed. The key press will still be displayed. So if we go back to that VM, and copy this file over again. Nope. Desktop sudo /Twitch Keylogger. Put in the password for the root account. We then come to text edit. We can see now that the key events are being captured and the key are still being delivered to the application, which is good, right? You're writing a keylogger, you want to capture the key presses, but you don't want to block them from being delivered. Otherwise, the user would obviously know something is going on. So the last thing we can do now is we can add the information about what specific key was pressed. Because right now we just say, hey, a key was pressed up or down. We don't actually say what it was. Was it an A, was it a B, etc. Obviously, you're writing keylog, you want to capture and log that data. So when the user types their password or some sensitive information, you capture that. All right. So I'm just going to copy and paste some code because it turns out it's actually not super trivial to do this, just because of the way of various languages and keyboard layouts, blah, blah, blah. So I will have a function that we can handle that. So let me just double check where that is. Okay, so, and this code, which I'm going to show you, is going to be online. Okay, so first thing we're going to do is we're going to grab the key code. And we will grab that from here. So again, there's an API to grab that key code. You call CG event get integer value from key, and you basically say, I want the key code from the event. And this will extract the key code. Now I wrote a method or a function that will convert that key code to a printable string. So instead of getting a number like 50 or whatever, 41, whatever it is for A, I don't know the exact key code, it will print that. So let me just see if this compiles. Okay, awesome. So I wrote this function. Again, key code to string, it takes in a key code, and you can see it basically calls, we get the keyboard layout because you could remap your keys, right? And like your A could not be where the A key normally is. Once we get the keyboard layout, we basically call UC key translate, which translates this key code, which is basically some number, to an actual string. And then we generate a string and return that. So now if we compile that and come back to the VM, let's kill that and delete the keylogger. In theory, we should now get the actual values. So if you're going to type A, B, C, you can see that there's A, B, C. So if I typed hello, Twitch followers, you see all that. Obviously, if you are capturing these keystrokes, you're going to format this better, like we saw with the malware. You're not going to put a new line between all of that. But again, we've just illustrated how we can now capture everything that the user is typing. So you can see, for example, again, I'll type, A, B, C, capture that. So again, in a few lines of code, we basically wrote a very simple keylogger that actually functions well. The most complicated part was just this translation. You could do this probably offline on your command and control server. But again, just to reiterate, the important things are creating what is called an event tap, which we did via the CG event tap create API. This is an Apple API. We then added that event tap to the run loop, which is, again, it's just basically this main thread that's always running, listening for events. And then we enabled the event tap. When we created the event tap, we specified a callback, which is a function that will get invoked anytime the user presses a key press. And so once we have this callback, we get the event, we can see what type it is, and then we added some extra logic to translate the key event, which again is a numeric value, to an actual ASCII or printable string, for example, A, B, C. So again, Keylogger, pretty easy, few lines of code. I'd say 50 lines of code or less. Again, this is the main meat. That translation stuff is just spurious, makes for a better demo. So if you're interested in that specific code, I've written an open source project called SniffMK, and what it does is it sniffs mouse and keyboard events. So let me just post that link over here. And just to follow up some of these questions, is the callback regardless of focus or even if someone else is in a game? My understanding is since we registered a system-wide callback, that this will be captured, the callback will be invoked anytime there's a key event anywhere on the system. So even if your application is not in focus, which it normally won't be, right? Your malware will be running in the background as like a launch daemon hidden. You will get notification of that key press. So this is a very powerful capability. You can now very easily write a key press or a keylogger that again runs in the background, doesn't have an app icon, isn't going to show up, for example, on the dock. There's not going to be any UI indication that it's running. But even though it's not in focus, it will receive all key events, which you can log to a file or directly exfiltrate to a command and control server if you don't want to store that on a system. So again, check out this open source project. The open source project is used to sniff mouse and keyboard events. It was actually designed to analyze a piece of malware, fruit fly, which synthetically could generate mouse and keyboard events. So I needed a utility that could capture that. So this malware was pretty cool because what the attacker could do is from their command and control server send synthetic key events, which would then be displayed on the infected system. This would allow them, for example, to interact with security alerts or prompts when the user wasn't around. I mean, they could have also like typed on the user's Word document or in the URL bar, but that would be obviously a dead giveaway that the system was infected. What the attacker would likely do is use these synthetic key presses to interact with system components of the system. They also had the ability to generate synthetic mouse events, move, click, etc., etc. So again, I needed a utility to monitor that, and a key logger and a mouse logger is also a sniffer. So obviously you can see that such tools can be used for analytical purposes, defensive purposes, or they obviously have more offensive capabilities as well.